Hello, and welcome to Chapter 5, Section 8, Graphing Absolute Value Functions. In this section, we will learn to graph an absolute value function and translate the graph of an absolute value function. So our essential understanding for this section is you can quickly graph absolute value equations by shifting the graph of y equals the absolute value of x. We're going to take a look at the graph of y equals the absolute value of x, and we're going to compare everything in today's work to that original graph. So as we take a look at the graph, it is kind of unique because it does make a V shape. This is not a linear graph. A couple things I want to point out. First of all, you should probably get a very good mental image of this in your head because you're really going to need to refer to it to compare for your answers today. So a couple things I want to point out. The vertex, or that meeting point where this V connects or touches, is right here at the origin, that point 0, 0. Now it does have two lines coming off of that. And on both sides, to find points on that line, to draw that line, we just go up and over one. So up and over one, up and over one, up and over one. And that would easily let us draw that line. Same on the other side here, up and over one, up and over one, up and over one. One thing I do want to point out, technically there are two lines coming off of this. So this line would have a positive slope because it goes up from left to right. And this line would have a negative slope going from left to right. We're not going to use that today, but just something to put in the back of your head. All right, so let's talk about the rules we have, all right? We're going to be given examples today where it's not going to be just y equals the absolute value of x, but we're going to look at the differences between the examples we're given today and this original y equals the absolute value of x. So we can quickly graph these functions just by shifting, or the word we're going to use today is translating the graph of y equals the absolute value of x. So it's very important that you're able to keep a mental image of that in your head as we go through these examples. As we look at these examples, when there's change or there's something different inside the absolute value bars as opposed to our original y equals the absolute value of x, that's going to result in a horizontal change or a side-to-side change. I'll kind of draw a side-to-side arrow. We're not going to draw side-to-side arrows, but I just want you to remember that horizontal means side-to-side. But it will be a horizontal change from the original graph. So an example here, y equals the absolute value of x plus 2. Well, this is different from the original, right? There's a plus 2 inside the absolute value bar. So since this is different, it's inside, meaning we're going to shift or move this graph horizontally. In fact, we're going to move it exactly how it tells us, plus 2. When it's inside the absolute value bars, since it's horizontal, plus means to the right, and 2 means 2 units. So we'll take the original graph, and we'll just shift it or move it over 2 units to the right. When there is some change or there's something different on the outside of the absolute value bars, this will result in a vertical change. So refresher on vertical, that's up and down. So this example right here, y equals the absolute value of x plus 2. Well, this is not the original. This is a little different. So what's changed or what's different? Well, we have a plus 2 on the outside. When it's on the outside, we're talking about vertical change, up and down. So when we're talking about up and down, positive always means up, and we'll move it 2 units. So this will just be the original graph translated or moved 2 units up on the y-axis. Now that looks great in words and text, but we really need to see this in action here. So here's an example. In the top right-hand corner, I'm going to put that original y equals the absolute value of x for you, just so you can you're really going to need to memorize it, or at least remember how to recreate it. So the example says use the graph of y equals the absolute value of x, so that's this right here, to graph y equals x minus 2. Now you have to remember the rule. If there's something different or there's change to the original on the outside of the absolute value bars, well, that means we're going to change vertically. So since we're changing vertically, we know the direction. Minus 2 means down, so we'll move down 2 units. So the way we do that, remember the vertex, that point I was talking to you about? Usually that vertex is in the middle, right, at the origin, 0, 0. But now we're going to move everything down 2 units. So the easiest way to draw the answer or the graph for this example would be to Move that vertex down 2 units. So now the vertex is here at 0, -2. And then to draw the arrows going left and right, I remember that the line, every point on the line is up and over 1. So up and over 1 to get to a point, up and over another one to get to a point, up and over 1, and then you can draw that line. Same on the other side. Remember, because it's a V-shaped, we need both lines. So up and over 1, up and over 1, up and over 1. And that would be our answer. This black graph representing the function here, y equals the absolute value of x minus 2. So here's your first U-try. Use that original y equals the absolute value of x, I've given it to you here as well, to graph y equals the absolute value of x plus 3. And this means that because there's change on the outside, you're probably going to have some vertical change here. All right, so that was the first rule. Let's take a look at when there's differences inside the absolute value bars. So again, we're going to use the original y equals the absolute value of x, and we're going to use it to graph y equals the absolute value, all in absolute value bars, x plus 2. Well, because it's inside, this means we have horizontal change. So we'll take a look at plus 2. When we're talking about horizontally, it can only go left or right. Plus means it's going to go to the right, and it's going to go to the right 2 units. So we start with that original vertex, which is at 0, 0. It always starts at the origin. And we're going to move it to the right 2 units. So it now becomes right here at the point 2, 0. And from there, we just finish the graph by knowing that the slope on both sides is 1 over 1. The rise is 1, runs 1. So rise 1, run 1, rise 1, run 1. And again, you can do that on both sides. That's it. We're finished here. We're just taking a couple rules and being able to apply it to a concept here. So here's your second and final U-try problem. Go ahead and graph it in your notes. You will not be able to put these in the Google form. But I do want to mention that because there's change here in the absolute value bars, you're probably going to have some horizontal movement. Do not end the video now because I do have another example I do want you to see after this. All right, sometimes we can see both rules happening at the same time. All right, this example is the graph of y equals inside absolute value bars, x plus 2, and then on the outside we have a minus 2. Because it's absolute value, we can't just combine the plus 2 and minus 2. That rule doesn't work for us here. What we have to do, though, to graph this, we have to remember that inside means horizontal change and outside means vertical change. So on the inside, this plus 2 means that I'm going to go to the right 2 units. And on the outside, minus 2 means I'm going to go down 2 units. So that original vertex, which is always at 0, 0, we're going to move it. And we're going to move it these directions. We're going to move it to the right 2 units and down 2 units. So to the right 2 units, down 2 units, that puts the new vertex right here. And again, we can finish off the absolute value graph by just remembering how to graph those 2 lines. And that's it. Not a lot to do or calculate or think about here. Just being able to follow 2 rules and being able to apply them in different settings.